In 1.1 there are two exercises, exercise 1A and 1B. So in this lesson we are going to go through exercise 1B. Usually when you take a quadratic equation, there are three cases. B square minus 4ac, the discriminant can be a positive number. In that case you will have two distinct real roots. For example, if you have x square plus 4x plus 3 is equal to 0, if you try to solve this, you will get x is -1, x is -3. These two real numbers. And then the case 2 is b square minus 4ac, the discriminant is equal to 0. In that case you have one real root, or sometimes we call it two equal real roots. For example, if you have x square plus 10x plus 25 is 0, you can try solving this using your calculator. You will get x is equal to -5. And then the third one is when the discriminant is a negative number. In that case, when you try to solve it, you won't get a real root, no real root. For example, if you try to solve x square plus x plus 1 is equal to 0, you can use your calculator to try to solve this. You will get complex numbers actually, -1/2 plus or minus I√3/2. So you have a complex number solution for this one, no real solution. So when you have a quadratic equation with no real solution, you can find complex roots actually, roots as complex numbers. For example, I'm taking a question from exercise 1B now. For example, I'm taking a question from exercise 1B now. Solve each of the following equations. Write your answer in the form plus or minus bi. So the easiest way to solve it is by making z as the subject. Z square is equal to -121. Z is plus or minus square root of -121. If you find the value of square root of 121, you will get 11. So you can write it as plus or minus 11i. That's the two solutions. For example, E now. You have z square plus 30 is equal to -3z square minus 66. Put this number here, 30 to this side. Z square plus 3z square, 4z square is equal to -96. So divide by 4, you will get z square is minus 2 4s are 8, 24, -24 if I'm not wrong. So z will be plus or minus square root of -24. Use your calculator and find the value of square root of 24, which is 2√6. So you can write it as plus or minus 2i√6. That's the solution for this quadratic equation. I'm taking one more question from the same exercise. Solving quadratic equation. You can solve the quadratic equation using completing the square or quadratic formula. I'm going to show you both methods actually. The first one is completing the square. Z square plus 2z, half of 2 is 1, so you put plus 1 square minus 1 square plus 5 is 0. That's the completing the square method, right? The first three terms can be combined as z plus 1 whole square, and then this one -1 plus 5 is 4, push it to the other side, is equal to -4. Hope you understand this step. I'm gonna take square root both sides. Z plus 1 is plus or minus square root of -4, and bring the 1 this side. Z is -1 plus or minus square root of 4 is 2, so you can write square root of -4 as 2i. So you got two solutions already. -1 plus 2i, -1 minus 2i. You can use quadratic formula for this also. You will get the same answer anyway. Now I'm going to solve the same equation by using quadratic formula. So we have a is equal to coefficient of x square, b is coefficient of x, c is 5. So the formula is minus b plus or minus square root of b square minus 4ac divided by 2a. So you will get minus 2 plus or minus square root of, if you simplify it, you will get 2 square is 4 minus 20 negative 16 by 2. Negative 2 plus or minus square root of 16 is 4, so square root of negative 16 is 4i divided by 2. Divide each term by 2 separately, you will get the same answer. So you can use either one of these method, whichever method you are comfortable with, either completing the square or quadratic formula. I'll take one more question from the same exercise. I'll take B now. You can use completing the square or the formula, you will get the same answer anyway. So B, A is equal to 7, B is negative 3, C is 3. So Z is equal to minus B, B is negative 3, plus or minus square root of B square minus 4ac divided by 2a. So we'll get positive 3 plus or minus square root of, use your calculator to simplify this. Minus 3 whole square is 9 minus 4 times 7 times 3, which is negative 75 divided by 14. So find the value of square root of 75. You will get 5 root 3. So it's 3 plus or minus, I think 5 root 3. Square root of 75 is 5 root 3. You will get 5i root 3 divided by 14. If they want in this form, a plus ib, like writing real part and imaginary part separately, write it separately. 3 over 14 plus I times 5 root 3 over 14. That's all. That's how you solve a quadratic equation which has no real solution. I have taken one more question from the same exercise 1b. The solutions to the quadratic equation are z1 and z2. Find each of them in the form of a plus I root b. It's another way of asking you to solve the equation. It's the same thing. So they did not specifically say completing the square or formula. So it's up to you which method you want to use. I'm going to use completing the square here. Z square minus 8z. Half of 8 is 4. So plus 4 square minus 4 square plus 21 is 0. If you combine the three terms, it becomes z minus 4 whole square, and this is minus 16 plus 21 is 0. Minus 16 plus 21 is basically 5. If you bring the 5 to the other side, z minus 4 whole square becomes negative 5. Take square root both sides. Z minus 4 is plus or minus square root of negative 5, which is basically plus or minus I root 5. Bring the 4 to the other side. Z is 4 plus or minus I root 5. They want the answer in this form, a plus or minus I root 5, where a is, they want you to find two solutions, z1 and z2, so write them separately. Z1 is 4 plus I root 5, z2 is 4 minus I root 5. Or you can swap them, doesn't matter. You can just put z1 as 4 minus I root 5, z2 as 4 plus I root 5, doesn't matter. One last question from this exercise. One last question. The equation z square plus bz plus 11 is equal to 0 has distinct non-real complex roots. When a quadratic has complex roots, the discriminant b square minus 4ac will be a negative number, less than 0. So in this case, A is from this equation, A is 1, B is B actually, C is 11. So B square minus 4AC is less than 0. B square is less than 44. So B is basically, if B square is less than 44, you cannot just take a square root and write it as a square root of 44. If B square is 44, you need to write it as a negative square root of 44 to 40. It can be a negative number also. So that's a proper way of writing it. And always write it in the simplified form. Put it in your calculator. You will get minus 2 root of 11 is less than B is less than positive 2 root of 11. That's the range of possible values of B. That's all.